accurately and fluently applying these operations in the real-world settings. Contextual problems are the primary teaching tool that you should use to help children activate problem-solving strategies and gain a rich understanding of the operations. For the action of joining, there are three quantities involved: an initial or start amount, the change amount, and the resulting amount. Separate problems are commonly thought of take away or take from problems in which part of the quantity is physically being removed from the start amount. Notice that in a separate problem, the start amount is the whole or the large amount, whereas the join problems, the result is the largest amount. Part whole problems are known as put together and take apart problems, which involves two parts of the conceptual or mental combination into one collection or whole. Pair problems involve the comparison of two quantities. The third amount in these problems does not actually exist, but is the difference between the two quantities. Conceptual problems, on the other hand, are connected as closely as possible to the children's lives, rather than the school's mathematics. Conceptual problems, on the other hand, are connected as closely as possible to other children's lives, rather than school and administration. Contextual problems have the potential to provide memorable imagery that can act as a touchstone for teacher and learners in building discussions about concepts. Contextual problems might derive from recent experiences in the classroom, a field trip, discussion in art, science, social studies, or from children's literature. Have students use words, pictures, and numbers to explain how they solve the problems and justify why they are correct. If a student struggles with a problem, use smaller numbers to see if it's the size of the number causing the obstacle. You can also intensify the challenge by increasing the size of the number. Many students will use counters, bar graphs, or number lines to solve story problems. When the parts of a set are known, addition is used to name the whole in terms of the parts. The simple definition of addition serves both action situations, join and separate, and static or no action situations, part, whole. Notice that in every example, both parts are distinct, even after the parts are combined. For children to see the relationship between the two parts and the whole, the image of the 5 and the 3 must be kept as two separate sets. The use of a bar graph as a semi-concrete visual representation is used to support students' mathematical thinking by generating meaning-making space. A number line measures distance from 0. Make sure to emphasize the unit length. Children may focus more on the tick marks instead of the space. If the total or whole number of tiles is 9, and 6 tiles are removed from under the cover, the children can think in terms of 6 and what amount added to 9, or what goes with 6 to equal 9. Discuss the difference between the two bars to generate the third number. If the students make a bar of 10 and a bar of 6, ask how many more do we need to match the bar of 10. The unmatched cubes in the larger bar show the difference is 4. The commutative property, sometimes known as the order property for addition, means you can change the order of addends and it does not change the answer. As this property is essential in problem solving, counting on from the larger number, mastery of basic facts. If you know 3 plus 9, you also know 9 plus 3. And the mental mathematics, there is a value in spending time helping children construct the relationships. The associative property of addition states that when you add 3 or more numbers, it does not matter whether the first pair is added first or if you start with any other pair of addends. The property allows for a great deal of flexibility so students can change the order in which they group numbers to work with combinations they know. Help students identify combinations of 10 from the numbers they are adding by mentally grouping numbers differently from just reading the expression from left to right. Connect the different meanings of multiplication and division to each other, along with connecting multiplication and division to addition and subtraction, and make sure you use these in real-world situations. Equal group problems involve three quantities: the number of groups, the size of the group, and the total of all the groups. When the number of groups and size of the groups are known, the problem is multiplication, situations in which an unknown product, how many in all, when either the group size is unknown, how many in each group, or the number of groups is unknown, how many groups, then the problem is division. If the number of groups is unknown, but the size of each group is known, the problems are called measurement division or sometimes repeated subtraction problems. In multiplication comparison problems, there are two different sets or groups. In multiplication situation, the comparison is based on one group being a particular multiple of another, a reference set. In these comparisons, there are three possibilities for the unknown: the product, the group size, the number of groups. The array is a model for an equal group situation. It is shown as a rectangular grouping with the first factor, the number of groups, representing the number of rows, and the second factor, the number of items in each equal group, representing the equal number found in each row. Rectangular shape, the product of two lengths, length and width, in an area usually measures in square units. 4 feet times 7 feet is not 28 feet, it is 28 feet squared. The factors are each one-dimensional entities, but the product consists of a two-dimensional unit.